Today we're going to talk about piecewise defined functions. So we're going to look at evaluating and also look at finding the domain and graphing of our equations. And we'll get to writing the equations of graphs later. So for the piecewise defined function, find each of the following. So we talked about this last year, that a piecewise function is a function whose rule includes several formulas. The formula for each piece of the function is applied to certain values of the domain as specified in the definition of the function. So if you look at question 1, we have our piecewise function f of x, and you notice that it has two different equations with rules for the values of x. So we have to figure out where these x values fit. So looking at the first one, if we have a is f of 0, then the x value is 0. So you have to look at the rules for those equations. So where does 0 fit into? Is 0 less than 2 for the first equation? Yes, it is. 0 is not in between 2 and 20. So that tells us we're using that top equation to evaluate our function. So we would get 0 squared plus 2 times 0, which of course is just 0. Looking at the next one, 3.6. So 3.6 is not less than 2, but it is in between 2 and 20. So that means we're going to use that bottom equation. So 3 times 3.6 minus 5 would give us our answer of 5.8. The next one's f of 24. So 24 is not less than 2, and 24 is not in between 0 and 20, or excuse me, 2 and 20. So therefore, this is not in the domain, so this is undefined. So if we want to find the domain, you could, if you wanted to graph this out to look at the graph, you could also just make a number line to think about the values that you have and look at your turning points. Remember, the turning points are the values for which the graph is changing to the other equation. So we have 2 as a turning point and also 20. So at 2, our first equation has an open circle because it's not equal to, and it says x value is less than 2, so that would go this way. And then the second equation is at 2 to 20, so that would be a closed circle because we're including 2 and closed circle at 20. So to find the domain, you're looking at where they are overlapping. So they overlap from negative infinity, and even though there's an open circle here, we have a closed circle that takes care of the value of 2 all the way up to 20. So that means that the domain would be negative infinity, using a parenthesis, to 20 bracket. So go ahead and pause the video and do the next one on your own, and then unpause to check your work. So looking at question number 2, we have h of x as our functions, and we want to evaluate h of 0. So 0 is not greater than or equal to 4 for that first top equation, but 0 is less than 3, so we're going to use the bottom equation. So we have 2 times 0 plus 15, which gives us 15. 3.5, so if you look at this, 3.5 is not bigger than or equal to 4, and it's not less than 3, so this is not in the domain, so undefined. H of 4 is going to fit into that top equation because 4 is greater than or equal to 4, so we have 3 times 4 squared minus 5, which is going to give us 43. And the domain. So again, if you want to make a number line, we have on our number line 3 and 4. So for 4, it's a closed circle. We have values that are greater than 4, and for 3, it's an open circle and less than that. So these don't have any overlapping values, so just wherever we have our line would be our domain. So that means our domains from negative infinity to 3 parenthesis union bracket 4 to infinity. So that's for evaluating our piecewise function. Now we're going to take a look at graphing. So we need to be able to graph these without our calculator, but we can use our calculators to help check our work when we're done, which we'll do after we graph them. So looking at the first one, notice that the equation has 2 different rules for the function. So that means 2 different pieces. The first one's a quadratic function for x values that are less than or equal to 1. So we graphed piecewise functions last year. So remember, you always want to start at wherever your turning point is. So we're going to start with an x value of 1 and plug it into our function. for x squared. So 1 squared is 1, and of course that means we have the point 1, 1, and because it's x values less than or equal to, we're going to use a closed circle there. So then numbers less than 1 would be 0. So 0 squared is 0. Negative 1 squared is 1. Negative 2 squared is 4. Negative 3 squared is 9. So this is my graph of my quadratic equations for x values less than or equal to 1. Notice we're not drawing the other half of my quadratic function or the parabola because, again, we only want x values less than or equal to 1. So then the second equation is for x values in between 1 and 4. So we're going to use those values of the turning points to help us start. So if I plug 1 into my equation, 1 plus 2 gives me 3. So at 1, 3, I have an open circle. And then I'm going to use 4. So if I plug in 4, 4 plus 2 gives me 6. And that's a closed circle. And of course, you can see this is just a linear function. So the slope of the line is 1. So we can just go up 1 over 1, and then we're going to use our ruler to connect those values. I got my ruler here. Every time you have a straight line, you should always use a ruler to connect the values. And so that gives me my piecewise function graph. And like I said, we can also use our calculator to check this. However, we're not going to have our calculator for a quiz, so you need to know how to do it without your calculator. But let's go ahead and plug this in. There's different ways of plugging in this notation. So the first thing I'm going to do is go to my second y equals. And if anytime you have a stat plot turned on, you always want to make sure to turn those off because your calculator gets confused at whether or not to graph the stuff that's in the scatter plot or to graph what's in your y equals. So now that that's turned off, I'm going to go to my y equals, and I have two different rules. So there's different ways you can plug this in. The first way is you can plug in each equation into separately in y1 and y2. So we have x squared, and then to get the restrictions, you use the division symbol, and then always use parentheses around your restrictions. So then we have x values less than or equal to 1. So we type in x. And then to get the less than or equal to, if you go to second math, notice it says test. That gives us our inequalities right there. So we want less than or equal to, which is number 6, and then 1. And then in y2, you can do the second equation. So we have x plus 2, and then the division symbol separates the restrictions. And this is for x values in between negative or 1 and 4, but we can't put this all together because your calculator gets confused for some reason. So you do have to write this out separately. So if I'm writing this in my calculator, it's actually written down here on your paper. So if you want to go ahead and look at that, you would have to write it in with the values separate. So x is less than 1, or excuse me, x is greater than 1, but less than or equal to 4. So we're going to have to do a double set of parentheses here. So we have x, or actually we can do 1 first, doesn't matter. 1, second math to get those inequalities is less than, which would be 5, x, and then close parentheses, parentheses, x is greater than or equal to, so second math, and then greater than or equal to is number 4, and that would be 4. And then don't forget to close those parentheses. So if we do that, and then I'm going to hit zoom 6. Zoom 6 is a standard window. So when it gives you a standard window, it means your x values come from negative 10 to 10, and your y values go from negative 10 to 10. So notice that is what our graph looks like here. But it's, you can't really tell where your open and your closed values are. And so that makes it a little bit difficult. So then that's why you have to know how to do your open and closed circles on your graph. And I just realized I put x values greater than or equal to 4 right here. So I need to fix that second math. We're just going to write over. It should have been less than or equal to. I was wondering why my graph was all the way over. So number 6. Okay, there we go. That should be better. So now I can hit graph. All right, that looks better. So notice this is what our graph looks like. But again, it doesn't tell you where the open and closed circles are in your graph. And if you go to the second graph, which is your table, I need to change this back to auto. If I go to second graph, which is my table, you can see y1 and y2. So for the first graph, which was quadratic, you only have graph x values that are less than or equal to 1. And then the other graph, when you plug in 1, it doesn't, you know there's going to be an open circle there. So you have to include that in your graph, but it doesn't tell you where it is. That's why you have to know how to plug that in. And then you have values from just, again, 1 to 4. The other way you can do this is to plug it all into your y1 and just use a plus sign to separate in between the functions. So I'm going to do that by just using my y2 to make it easier. So I'm going to go down to my y2 here and just do second delete, which is insert. So we have x squared and then the division symbol and then x values, second math that are less than or equal to, which is number 6, 1. And then if you put a plus sign in between and then parentheses around the x plus 2, I'm going to clear this equation out. So if I hit graph, it should give me the same equation. Oh, hold on. All right, so for this one, I had to play around with it a little bit. You actually don't use the division symbols when you put it all together for the second way. So notice I took out the division symbols here. So it's just x squared and then parentheses with the restriction plus x plus 2, and then again, no division symbol. So when you do it this way and hit graph, you get your equation. And then this one's nice because when you go to your table, it'll just kind of go through. It doesn't show you which equations which, it just kind of goes through. But again, this one you'd have to be careful because at that turning point of an x value of 1, again, notice that it gives you 1, 1, but it doesn't tell you that right here you're starting at 1, 3. You'd have to know to plug that in because otherwise you would think your graph didn't have that circle there, and you might start your graph right here like this, and then graph it from there to there, which would be incorrect because then you're missing all the values in between. So I'll make sure to fix that. So again, no division symbols in that one. So just make sure to cross that off. All right, so let's go ahead and look at our next equation. So for the next one, we have 3 different equations. So we're going to have 3 different pieces to our graph. So the first one is for x values that are less than -1. So we're going to start with our -1, our turning point. So if I plug -1 in for x, 2 times -1 is -2, minus 3 gives us -5. So we have -1, -5. It's not equal to, so we're going to have an open circle. This is a linear function, so you could plug in -2 if you want to find the next point, or you could just use the slope. You know the slope you're going to, it's rise over run, so up 2 over 1. So since we're going to the left, we're going to go down to left 1. And that would give me my line. And then for the next one, notice that we have the absolute value function, absolute value bars of x minus 1. So this, remember, from our transformation, moves our absolute value graph down 1, and we're looking at graphing it from -1 to 2, including both those values. So if I plug in -1, the absolute value that is 1, 1 minus 1 is 0. So we have a closed circle here. If I plug in 0, the absolute value that is 0 minus 1 is -1. The absolute value of 1 is 1 minus 1 is 0. And if I plug in 2, the absolute value of 2 is 2 minus 1 gives us 1. So this, remember, makes our V-shaped graph. And it's always good to kind of think about where your vertex is to make sure you're getting that V shape. And then for the next one, we have, again, a quadratic function for x values greater than 2. So 2 squared is 4. So I have 2, 4 with an open circle. And then 3 squared is 9. And again, it's not going to be a straight line. It's going to be kind of curved. So because it's a quadratic function, so just kind of think about that when you're graphing these. So that gives me my piecewise defined function. So again, if you wanted to practice plugging this into your calculator, you could plug them each in separately, which is usually what I do, or you could plug it in all together without the division symbols if you wanted to. So let's go ahead. I'm going to quickly just plug this in without doing it separately because that's what I'm used to. So we have 2x minus 3, and then we have that 4x values that are less than 1. Excuse me, -1. And then to get absolute value, you can hit second catalog, and the first one is the absolute value. So we have the absolute value of x, and then -1, and that's for x values between -1 and 2. So you have to do that separately, remember. And don't forget to do the double parentheses, and then we have x squared, and that's for x values greater than 2. And if I hit graph, it should work. So there's our first part of our function, there's the absolute value, and then there's the second part. It's hard to see this V shape here. You could zoom in if you wanted to. And then you could also confirm your values, and to get your third one, you can just scroll over to see there's y1, y2, and y3 values. Remember, this is quadratic, and since when we plug in 2, there's an open circle, that's why it doesn't show you there. That's why you always want to do these by hand. So that's it for graphing our piecewise functions. And then we have one more piecewise function, which is the greatest integer function, which we briefly talked about the other day. So the greatest integer function is a piecewise defined function with infinitely many pieces. For any number x, you're always rounding down to the nearest integer less than or equal to x. So the rule of the function is f of x equals, and again, we use these brackets around the x to stand for the greatest integer function. And some books do use, again, a double bracket that looks like this so that people know that it's the greatest integer function, because sometimes people use brackets for like parentheses purposes. So it's good to know the different notation. The domain's all real numbers and the range is integers. So if we're always rounding down to the nearest integer, so let's start at 0. 0 is an integer. So 0, from 0 to 1, at 1 we would have an open circle, because once you get to 1, then that's an integer, and so you have to jump up to here. But anything in between 0 and 1 is going to round down to 0. So like if I were to do, so we have f of x equals the greatest integer of x. So if I plug in f of 0.1, that's rounding down to 0. F of 0.2 rounds down to 0. F of 0.3 rounds down to 0. All the way up to f of 0.9999 is still not an integer, so that rounds down to 0. But as soon as you get to f of 1 and plug that in, that's an integer, so that's at 1. So then same thing, f of 1.1 round down to 1. F of 1.2 rounds down to 1. F of 1.999, etc. would round down to 1. But as soon as you get to 2, then you're going to jump to that new integer value. So this looks like kind of like steps. Some people call it the step function, but that's not actually the name. It's called the greatest integer function. And that goes on for each different integer that we have. So usually if you use those 3 dots to denote that it's going to continue. So going the other direction would look the same and just continue. You can kind of think about it like your birthday. So for your birthday, you don't turn the next age until you actually have your birthday. So for the entire year, let's say you're 16 years old. So for the entire year, you're 16 until you have your birthday, and then you turn 17 and you jump up to the next integer value that you have. So it's kind of like that. And so that was what the graph would look like. And so let's evaluate some of these. So if you plug in -5.1 in for x, a lot of times students have difficulty with the negatives here. So this rounds down to -6. So think about it as a number line. So we have -5 here, this is -4, and this is -6. So you have -5.1 is here. Remember, you're rounding down to the nearest integer, so that rounds down to -6, not to -5, which is what students usually try to do. So 3.2 rounds down to 3. 5/4 would round down to 1. 0 is an integer, so that's just 0. Pi we know is 3.14, so that rounds down to 3. And there is a place in your calculator where you can also go to get the greatest integer function. I think if you go to math and then scroll over to number, if you look at number 5, it says int. So even just to show you, if I did negative 5.1 and plug that in, notice you get negative 6. So I'm just going to go ahead and copy that again. So if I did pi in here, so to get pi second and then above your division symbol is the caret key, that gives you your pi, and notice that gives us 3. So that is, again, under math, right arrow to number, and then number 5 is the integer. And so even if, oops, let's go back. So even if we were to go to the graph, just to show you on the graph. So if we go to the graph of this, math number 5 of x, it looks like kind of steps. But again, it doesn't show you where the open and close part of the circle is. You have to know that on your own. All right, so the next one, you can pause the video, graph this on your own. When you're done, on pause and check your work. So to graph this, we have 2 different pieces of our function. For the first one, we have a quadratic function for x values less than or equal to 2. So I'm going to start at my turning point, which is 2. 2 squared is 4. 4 plus 2 gives me 6. So I have 2, 6, and it's equal to, so it's a closed circle, and we want values that are less than 2. So if I plug in 1, 1 squared is 1 plus 2 is 3. 0 squared plus 2 would give us 2. Negative 1 squared is 1 plus 2 is 3. And then this would be 6 again. And again, that is quadratic, so it makes that U shape or parabola. And then for the next equation, we have 1/2 x plus 1 for x values greater than 2. So if I start again with my turning point at 2, 2 times 1/2 would be 1, and 1 plus 1 is 2. So we have 2 with an open circle because it's not equal to, and I'm going to use this slope to help me graph this. So we're going up 1 over 2, up 1 over 2, up 1 over 2, and then we're going to use that ruler to connect those points. And so that gives me my piecewise graph, and then it's asking to find the domain. So now you can look at the graph and see the domain would be all real numbers, because even the place where we have a jump, that x value is taken care of on the quadratic graph up here. So domain would be -infinity to infinity. And again, you could also make a number line like we did earlier in this unit. So that is it for our piecewise functions and our greatest integer functions. And actually, before we stop, let's go ahead and do one more problem. Let's go ahead and write the equation for the piecewise function below. Sometimes they'll say write the rule. So let's call this function g of x. So we can see that this has 2 different pieces for our function, because you can look at those turning points that you have. So right here, it turns from this line up here to this bottom line with the open circle. So we have 2 different pieces. So the first one, we have to write the equation for this line. So we have to think about what type of function is it. It's a linear function. So linear functions, we have y equals mx plus b. So the slope of the line is 1. And our y-intercept is also 1. So for this, we have 1x, which you don't have to write 1x, plus 1. And this is for x values, if you look in between -4 and 1, including, because they're both closed circles. So from -4 is less than or equal to x, which is less than or equal to 1. And then for the other line, we have an open circle here at 1, and it's going to 3. And so for this, we have to find the y-intercept and the slope. So the slope of the line in this case is -1, because it's going down 1, right 1, down 1, right 1. And if you go up 1, left 1, then you would see that if this line continued, it would hit a y-intercept of 0. So the y-intercept is 0. So the equation would be negative x, and this would be for x values in between 1 and 3, but not including 1. So we have 1 is less than x, which is less than or equal to 3, and that would be the equation or the rule of our piecewise defined graph. And that's all for today.